Yeah, Emily, go ahead.
Is it the alternate interior?
Yeah, exactly. So here's my transversal, and these angles are on opposite sides or alternate sides. So alternate interior angles. So now I can look at my chart and go, okay, this is from notes yesterday, alternate interior angles. That's in the column. Sorry, my cat is attacking a piece of paper behind me. That's in a column saying that they are congruent angles, so I can set them equal to each other. So this is going to help tell me how I'm going to set up my equation. So my equation would be x plus 116 equals 110, setting this angle equal to this angle, they're congruent, and then I just have to subtract 116 to solve for x, okay? So hold on 1 minute. Okay. Then on number 2, that's a different, yeah, exactly, same side interior. So again, here's my transversal. This time they're on the same side, still on the interior of that diagram. And I go to my handy dandy chart and I'm learning what the relationships are. Same side, so loud in my house. Same side interior are supplementary, and it shows me above what that setup means. So that means that one angle plus another angle equals 180 degrees. So different equation setup than what I had here. Knowing that these are same side interior, my setup's going to be 24x plus 4, this angle, plus my other angle, 21x minus 4, is going to equal 180. Same side interior are supplementary. These are equal to each other. Okay. So now let's see, I have 45 x's all together, and then 4 take away 4 is going to cancel, equals 180. And just use our calculator real quick. 180 divided by 45. It doesn't go in evenly, does it? My calculator's frozen. Hold on. Oh, it does.
Yeah, x equals 4.
X equals 4. Good. Okay. So then, and this is part of your checkout today. So this is really good practice for what you're going to get a grade on later today. So 3, what angle relationship do I have there? Here's my transversal. Alternate exterior. So similar to this, alternate sides, but this is interior. Here we have exterior. So we have alternate exterior, interior, or exterior. Both are congruent or equal to each other. So I have 7x plus 17 equals 80. And subtract 17. And 7x equals 63. And divide by 7. And x equals 9. Good. On 4, this is the trickiest angle relationship to recognize. What is this angle relationship called? They are same side, but they're not both exterior. So this one's exterior, this one's interior. What do we call that?
Corresponding.
Corresponding angles. So these are corresponding angles, which again, if you aren't sure what their relationship is, check the little chart. These are congruent to each other. So I'm going to set them equal. 12x plus 7 equals 127, or 12x equals 120, and x equals 10. Okay, so solving using those angle relationships. And what you'll see, let me just stop share for a minute. And then I don't see it. Okay. I'm just looking for your classroom. So in classroom today, you have a checkout, and the first part of that checkout, can you see it now? Hopefully you can see what I'm talking about. first part of that checkout, you're just deciding which relationship do I have. So there's A, B, C, D, which one is it? But then on the second page, you're doing exactly what we just did. Okay, so you have to first determine what's the relationship. And so then what does that mean? How do you set up the equation and solve? Okay, so this warm up today should help you with that. Okay, so now, let me do a new share. Let me go back to the, we did not quite finish notes number 2 yesterday. So again, if you haven't gotten those down yet, you definitely want to go and watch that video, get the notes down. I'm not sure, the completed notes, like the scanned in notes, those are last semester's scans. So I'm not sure if it had everything that we covered yesterday. We covered everything except for the last page when I scanned in what we have. So if you could find your notes and find in notes number 2, so here's the page before, find this last page of notes. And we're just going to go through. I wanted to make sure we did one of these proofs together before I let you go, because it's on your homework that'll be due. Okay, so at the top, it goes back to, you'll notice it has if, this, oops, went too far, then that. Okay, and we use in our proofs in particular these if-then statements that are from last unit over and over again. So it says if 2 lines are parallel, then the following is true, and it's really just giving us a list. So alternate interior or alternate exterior angles are congruent. So just to kind of give us an example, in a proof, maybe I write if, and I don't have to write parallel, I can just write the symbol for parallel. If parallel, then alternate interior angles are congruent. Okay, that's just an example. Or it could go the other way. If I knew that alternate interior angles are congruent, then I know my lines are parallel. So those if-then statements can work both ways, depending on how I need them in my proof. Okay. Same for corresponding angles. So corresponding angles are congruent if parallel, and corresponding angles are congruent, and vice versa. I can flip these. The converse of that original statement is also true. Now I take a lot of points off for this. The same side angles are not congruent, they're supplementary, and students tend to want to write the if then always the same and end with congruent. So we still are going to write an if then, but it would be if parallel, then, and I'll just choose one of them, same side exterior angles are supplementary. Make sure we change what the relationship is. If this, then supplementary, not then congruent. Or again, vice versa. Okay, we do not use this for vertical angles or linear pairs. We talked about that earlier in these notes, that has nothing to do with parallel lines. So if I'm saying 2 angles are equal just because they're vertical angles, has nothing, I don't need an if-then statement to say that. Vertical angles are always congruent, so I just say vertical angles. So thinking about writing proofs, what this next part gives us, this is like what we had on our test last time. We're given something, so what's the next statement I can make and why? So essentially what we don't know if lines are parallel here or not. But if one of these is true, then the lines are parallel. That's what's important about going this way. Okay, if one of these relationships is true, then the lines are parallel because this is only true when parallel. Okay, so if, for example, I was told that 5 and 3 or 3 and 5 are congruent, that information tells me that this line is parallel to this line, that M is parallel to N. I can't assume M and N are parallel unless I have a piece of information like that, okay? The reason that I know that M and N are parallel is because 3 and 5 are what type of angles?
Alternate interior.
Alternate interior. So my reason, if say this was approved, so here's my statement. Okay, so then these lines are parallel. My reason, it would be if I have alternate interior angles that are congruent, then those lines must be parallel, because that's only true when lines are parallel. Okay, that's where those if-then statements come into play. Another example, if I was given 3 subs 6, so 3 and 6 are supplementary. My conclusion again would be that these lines are parallel because 3 and 6 are what type of angles? 3 and 6.
Same side interior.
Same side interior. So I have to be careful with my statement. If same side interior angles are supplementary, then my lines must be parallel. Okay. And think about the order, like what do you have here? I have angles, so I'm saying parallel. If I had parallel, and so then I wanted to say some angles were congruent, that's when it would be flipped around and it would go the other way. The if then would go the other way around. Last one is 1 and 5. So if 1 and 5 are congruent, I can also again say those lines are parallel because 1 and 5 are corresponding angles. So if corresponding angles, and again are congruent, then parallel. So just be really careful. Are you saying congruent or supplementary means parallel? Okay, so those are like little mini proofs. So now let's use these if-thens in a very short 4-step proof here, where we're given some things and we want to prove that these lines are parallel. So we don't know that A and B are parallel right now, but we're going to prove that they are. So same as last unit, start with our given. So angle 1 equals angle 2, given. And angle 2 equals angle 3, given. And then so let me mark that 1 and 2 are congruent, and 2 and 3. So then what do we know is true? If 1 is congruent to 2 and 2 is congruent to 3, what else must be true? First of all, neither of those tell me that A and B are parallel right now. 2 and 3 are corresponding, but they're corresponding for these lines, not A and B. And I'm trying to say A and B are parallel. 2 and 3 are corresponding angles on the other lines that aren't even labeled. So that doesn't help me. 1 and 2 are also not anything in relationship to A and B. But if I know 1 is congruent to 2, and I know 2 is congruent to 3, I also would know what 2 angles are congruent.
3 is congruent to 1.
Yeah, that if they're both equal to 2, then 1 and 3 must be congruent to each other as well. Okay, 1 and 3. Now, I would take substitution because technically you could say 1 and 2 are equal, so I could substitute 1 in. But really that's that special where it's like a chain and they're linked together, that transitive property. I'll put substitution here as well. I would really take either one if it was a fill in the blank proof. So I like 1 and 3 because if I'm looking to prove that these lines are parallel, 1 and 3 have what type of relationship around lines A and B? What relationship do 1 and 3 have?
Hold on 1 second.
Maybe you want to flip it this way.
Yeah, they have corresponding
Well,
angles.
no, because they're on opposite sides. They're congruent. I like it. But what is this?
Alternate exterior.
Alternate exterior. So sometimes you gotta kind of flip your diagram around. If I'm trying to prove these lines are parallel, I'm looking to see what do these angles have around those lines. So I have two transversals going through that line. I really just want to focus on this one, and they're on alternate sides of that transversal. So because we've said that they're equal here, and we see that they're alternate exterior, then I can say that A is parallel to B, because if alternate exterior angles are congruent, then lines are parallel. That's where that if then statement comes into play on our proofs. Okay. So today, in terms of work, so everyone's kind of in a different spot. Make sure you've submitted homework 15. We went over this in class yesterday if you were in class with me. In terms of notes, you should have notes 1 and 2 done. This is a really quick unit. So there's notes 3 that we're going to take in class tomorrow, and that I'm going to also post those later. I just want fresh notes that are a little clearer to see. So there's only 3 sets of notes, and then we're taking a quiz at this time next week. So what was I just saying? So before you come to school tomorrow, make sure you have notes 1, notes 2 done. Homework 15 should already be submitted. You weren't quite ready to finish 16 yet, but now you are. So you can do everything in 16 now. There's a little fill in the blank proof here. And we'll go over this in class tomorrow. And then you also have a checkout that's posted in there today. And really, classroom's the place to look, right? If you're not sure what you're missing, go through and see what assignments you have posted in classroom that you haven't passed in yet. Okay.